name is Shubaika binti Badru and metric number AA210241, and now I want to present about introductions. Cyanobacteria are photosynthetic organisms that produce distinct kinds of pigments in order to harvest light. Such pigments are usually grouped in three major classes: chlorophyll, carotenoid, and phycobiliproteins. Chlorophyll is the most fundamental one. It is responsible for oxygenic photosynthetic activity, and it is present in all photosynthetic cyanobacteria. Carotenoids can be both primary and secondary pigments, and the profile change within the species and growth conditions. The most well-known and commercialized ones being astaxanthin, lutein, and beta-carotene. Moreover, phycobiliproteins are a special class of pigment present only in cyanobacteria and represent the major light absorber in this organism, where the most well-known phycobiliproteins are phycocyanin and phycoerythrin. Pigments from cyanobacteria are known for highly attractive properties for industrial use in food, feed, pharmaceutical, nutraceutical, and cosmetic, mainly due to their color and biotic properties, but also for being natural and eco-friendly component. Cyanobacteria can be sold both as raw biomass, dry, or processes for the obtention of specific compound. When only a specific compound in the final product, it requires downstream processing of extractions and possibly purification. The cost for the production of purified pigment is still high, and it restricts the applications to high-value markets, for example, as cosmetics. Three cases of successful productions of pigment from cyanobacteria are known: phycocyanin from Arthrospira platensis, beta-carotene from Dunaliella salina, and astaxanthin from Haematococcus pluvialis. Several factors can affect the extractions of pigment, including the target pigment, organism, market trend, available technology, and cost. Extractions usually requires a cell destruction method and a compatible solvent. However, it is also possible to extract some of these compounds without a cell destruction process using the so-called cell milking, where the product is extracted while the culture grows. In general, extractions can be performed using two distinct kinds of methodologies. First, non-mechanical, such as chemical, thermal, and enzymatic. Second, mechanical, such as pressurized system, ultrasonications, microwave, electric fields, and supercritical extractions. Some systems are based on a synergy between non-mechanical and mechanical characteristics, considering the effect of solvents, temperature, and the technology mechanism. For example, microwave-assisted extractions and ohmic heating. This review will cover the most commonly used technique for the extractions of pigment from cyanobacteria, paying particular attention to carotenoids and phycobiliprotein. The main advantage and disadvantages of each extraction technique will be highlighted, and some insight into the process optimizations for specific cultivations of organisms and productions of pigments will be addressed.
Process production that we use is extraction. Some extraction requires disruption method and compatible solvent. However, it is possible to extract the compound without cell disruption process called cell milking. Cell milking works on the basis of a two-phase cultivation system: aqueous phase, which is medium, and an extraction phase with a hydrophobic solvent. The content of the solvent with the cell creates pores in the membrane, exposing the target compound that passes to the solvent phase due to their compatibility and solubility in the solvent. The cells are then allowed to recover and produce more of the compound and possibly be made again in a short time interval.
Hi, my name is Rafiq Abiti Muhammad Roslan, and I'm going to present about comparison. First, in cell milking, cell disruption process was not occur, but in classic solvent extraction, the process is occur. Then, cell milking consists two phases of cultivation system, which are aqueous phase or medium, and extraction phase with hydrophobic solvent. No harvesting and recovery process are included. When the solvent in contact with the cell, it creates pore in the membrane, and the target compound will pass to the solvent, and the cell are allowed to recover and produce more compound and be milk again. While classic solvent extraction consists to mixing of the two pastes, which are solvent and biomass, solid will contact with solvent until equilibrium reach. Next, during cell milking, the product can be extracted while the culture grows, and this makes it can continuously operate in its optimal condition with suitable solvent. Compared to classical solvent extraction, is not continuous because the cell is fragile due to increase the efficiency. In addition, it uses thermal treatment, either heat or cold, which is caused to rupture to the membrane cell. Fourth, cell milking need less volume of solvent for extraction process compared to classic solvent extraction. Both solvent used in both methods was eco-friendly and safe to use. Solvent selection for cell milking are more detailed than classical solvent extraction. Lastly, the time interval to produce the extraction product for cell milking are less than the classical solvent extraction.
Assalamualaikum and hi, I am Siti Noizani binti Muhammad Nasri, meter sampai EE21136. I will present about graphic. Basically, our topic is about pigment extraction from cyanobacterial using biotechnology potentials. So the question is, how biotechnology can help to increase profit? First, simple extraction techniques. How it can increase profit? Due to the simple extraction techniques, the pigments are gaining commercial importance among the various bioproducts. Next, the cultivation phase can continue indefinitely, so it helps to reduce our costs because the cultivation phase still can continue recruit. Third, cost effective. Why this technique is cost effective? Actually, it's more focused on cell making technique because the technique is better efficiency rather than other extraction technique like classic solvent extraction. So it worth it for any industry to spend money on this technique. Last but not least, disruptive free technique. We used to hear that mostly any production can cause damage on machine or anything related to industry's tools, but this technique was perfect for any industry that involved in extraction because it's disruptive free technique, so it's one of the factors that can increase profit. So that's all from us, and we'll also give reference for our proof. So that's all from us. Thank you for watching.